Next problem. Find the finite Fourier sine transform of f of x is equal to x into pi minus x. So given, pi square minus x square, x into pi square minus x square. Given f of x is equal to x into pi square minus x square. That is equation number 1. We know finite Fourier sine transform defined in 0 comma pi is given by fs bar of p is equal to integral 0 to pi f of x sine px dx. That is equation number 2. Using 1 into fs bar of p is equal to integral 0 to pi x into pi square minus x square sine px dx. So that is equal to, we are splitting into two integrals. So first one x into pi square sine px dx minus integral 0 to pi x into x square, that is x cube sine px dx. So that is pi square is constant, take it outside from the integral. So pi square integral 0 to pi x sine px dx minus integral 0 to pi x cube sine px dx. That is equation number 3. Now consider the integral 0 to pi x cube sine px dx. We are going to evaluate separately and put it in the third equation, right? So using Bernoulli's theorem, we are going to evaluate this integral. So Bernoulli's theorem, integral u dv is equal to uv minus u dash v1 plus etc etc. As usual, we know u dash u double dash as successive differentiation of u, and v1 v2 are successive integrals of dv, right? Here we are taking x is equal, u is equal to x cube and dv is equal to sine px dx. Therefore u dash is equal to derivative of x cube, so 3x square. U double dash is derivative of u dash, that is derivative of 3x square, that is 6x. And u triple dash is derivative of u double dash, that is derivative of 6x, that is 6. And v is equal to integral dv, that is equal to integral sine px dx. You will get minus cos px by p. And v1 is integral v dx. V is minus cos px by p, right? Integral minus cos px by p dx, that is equal to minus 1 by p integral cos px dx, that is sin px by p. So you will get minus 1 by p square sin px. Then v2 is equal to integral v1 dx. So that is equal to integral minus 1 by p square sin px dx, which is equal to minus 1 by p square integral sin px dx. So integral sin px dx is minus cos px by p. So you will get 1 by p cube cos px. So v3 is equal to integral v2 dx, that is integral 1 by p cube cos px. So 1 by p cube integral cos px dx. Integral cos px dx is sin px by p. So you will get 1 by p power 4 sin px. Substituting in the Bernoulli's formula. So write integral 0 to pi x cube sin px dx, which is equal to uv x cube minus cos px by p, lower limit 0, upper limit pi, minus u dash v1 3x square minus 1 by p square sin px 0 to pi, plus 6x 1 by p cube cos px limit 0 to pi, minus 6 into 1 by p power 4 sin px limit 0 to pi. So substituting the upper and lower limit. So upper limit pi cube minus cos p pi by p minus 0 into something, so 0, minus next second one, right, minus 3 pi square minus 1 by p square sin p pi upper limit minus 0 into something, so again 0. Then third term plus 6 pi 1 by p cube cos p pi, then 0 into something, because we are putting x is equal to 0, right? 6 into 0 into something, that is why, right? 0. Then last term minus 6 1 by p cube p power 4 sin p pi minus 6 into 1 by p power 4 sin 0. So that is equal to pi minus pi cube by p cos p pi minus 3 pi square sin p pi is 0, so into 0, plus 6 pi by p cube cos p pi minus sin p pi is 0, 6 into 0, and sin 0 is also 0, minus 6 into 0. So we will get minus pi cube by p cos p pi plus 6 pi by p cube cos p pi, that is pi by p cos p pi is common, take it outside, remaining you are having into 6 by p square minus pi square. So that is equal to pi by p. Cos p pi we know value is minus 1 power p into 6 by p square minus pi square, right? So therefore integral 0 to pi x cube sine px is equal to pi by p minus 1 power p 6 by p square minus pi square. That is equation number 4. Next we are going to evaluate the integral, other one, right? Integral 0 to pi x sine px dx. So using same Bernoulli, here u is equal to x and v is equal to sine px, right? So u dash is 1 and v1 we know same as above, right? So v is minus cos px by p and v1 is minus 1 by p square sine px. So therefore integral x sine px dx equal to x into minus cos px by p, lower limit 0, upper limit pi, minus 1 into minus 1 by p square sine px, lower limit 0, upper limit pi. Applying lower and upper limit, so pi into minus cos p pi by p minus 0 into something, so 0, minus 1 by p square sine p pi minus 1 by p square sine 0. Sine p pi is 0, sine 0 is 0. So you will get minus pi cos p pi by p, right? So using so cos pi we know that is minus 1 power p, so you will get minus pi by p minus 1 power p. That is equation number 5. We are using 4 and 5 in 3. So fs bar of p is equal to pi square 0 to pi x sine px dx minus integral 0 to pi x cube sine px dx. Substituting the values, pi square into minus pi by p minus 1 power p minus pi by p minus 1 power p 6 by p square minus pi square. That is equal to minus pi cube, right? Pi square into pi by p minus 1 power p minus, we are multiplying, right? We are separating into two terms, right? Minus 6 into pi by p cube minus 1 power p minus into minus plus pi cube by p minus 1 power p. So first term minus pi cube by p minus 1 power p and last term plus pi cube by p minus 1 power p get cancelled. So you will get minus 6 pi by p cube minus 1 power p. Minus can be written as minus 1, right? Both are same. Minus 1 into something is equal to minus, right? So grouping minus 1 power p and minus 1. So answer is 6 pi by p cube minus 1 power p plus 1. Thanks.